Hello, and welcome to another Algebra 1 lesson. This is lesson 8.6. Our objective, determine if a function is linear, quadratic, or exponential. Essential question, how can you compare linear, quadratic, and exponential functions? Well, we can graph the points and look at the shape. We can find the first and second level differences of the y values, or we can look for a common ratio. Looking at these things can help us determine if it's linear, quadratic, or exponential. So, what are the graphs supposed to look like for each one? Linear functions are a line. Exponential functions get increasingly larger at an exponential rate. And quadratic functions are a parabola, a U-shaped curve called a parabola. So these are the shapes of graphs to look for when deciding if it's linear, exponential, or quadratic. Let's take a look at some functions. Example 1, plot the points. Tell whether the points appear to represent a linear, exponential, or quadratic function. Remember, when you graph points, to go over then up, x then y. Y is in the sky, x is over here. The point 4, 4, 2, 0, that's over 2, up 0, 0, 0, 1, negative 1/2, negative 2, 4. Well, it's definitely not a straight line, so it's not linear. Exponential? Nope, it's not just increasing, it is decreasing and then increasing. So if we were to connect those, that would be quadratic. It makes a parabola. Okay, graph the next point. See if you can tell what type of function that one is. We have worked with each one of these types of functions in previous units this year. Okay, graph your points. On your mark, get set, go. Remember, over then up. 0, 1, over 0, up 1. 2, 4. 4, 7, over 4, up 7, negative 2, negative 2, negative 4, negative 5, so back 4, down 5. What do you think? Looks like a line to me. So it is a linear function. Let's see, we have one quadratic and one linear. I wonder what the next one's going to be. Graph your points. 0, 2, so 0 left and right, up 2, 2, 8, so go over 2 and up 8. Keep graphing. So if we trace these connect them from left to right, it was going up slightly and then steeper and steeper and steeper, and the line keeps getting steeper. That is an exponential function. And that was example 1, using graphs to identify what type of function it is. differences, and ratios of functions. You can use patterns between consecutive data pairs to determine which type of function models the data. The differences of consecutive y values are called first differences. The difference of consecutive first differences are called second differences. I'll give you some examples of that in a moment. Linear functions have the first differences all the same. They are a constant number. For exponential functions, consecutive y values have a common ratio. That means you're going to multiply to get from one number to the next y value. And quadratic functions have the second differences that are constant. So linear have the first differences constant, quadratic functions have second differences constant, and exponential functions, those are the ones where to go from one y value to the next, we just keep multiplying by the same number. It's a common ratio. Example 2, use differences or ratios to identify what type of function it is, linear, exponential, or quadratic. So the first thing we're going to do, make sure the x values increase by the same amount each time. Okay, these increase by 1 each time, good. So now we're going to compare the y values. To go from 11 to 8, it goes down by 3, so we're going to subtract 3. This is known as the first level differences. From 8 to 5, that goes down 3. 5 minus 3 is 2. 2 minus 3 is -1. This is the first level differences, and they are the same. Because the first level differences are the same, that means it is a linear function. Now, if these numbers weren't all the same, we would find the next level differences of these numbers. So we might have to do that on one of the other problems here. Okay, check your x values. Are they increasing or decreasing by the same amount? Yes. Okay, as long as that's true, then we can start to compare these. 1, 2, 4, 8, and 16. Do you notice a pattern here? See, the pattern in the last one is it was going down by 3 each time. What's the pattern here? If you take the previous number and multiply by 2, you'll get the next number. So times 2, times 2, times 2. So the ones that multiply to get to the next number, those are exponential functions. Let's look at the third one. Can we multiply to get to the next one here? No. All right, if we're not multiplying to get to the next number, we're going to want to find these differences. How do we get from -1 to -2? We subtract 1, and then go from -2 to -1. We add 1, well, that's kind of weird. All right, keep going. How do you get from -1 to 2? What would we have to add? 3. And 2 to 7, we would add 5. Good. Okay, so that was the first level differences. Clearly, they are not the same. So if the first level differences are not the same, it is not linear. Okay, so now let's figure out the second differences. From -1 to get from -1 to +1, add 2. To get from 1 to 3, add 2. And 3 to 5, add 2. So these are the second level differences, and they are the same. So abbreviated differences. Second level differences are the same. So what type was that? Do you remember? It's not linear. It's not exponential. What was the other one? Second level differences are constant. Quadratic function. So this one is a quadratic function. Right, and that's example 2. First level differences are the same, it's linear. If the second level differences are the same, like the last one, it's quadratic. And if you have to multiply to get from one number to the next, and you get to multiply by the same number each time, then it's exponential. All right, give it a try. Pause your video, graph these points, see if you can tell which type it is, linear, exponential, or quadratic. On your mark, get set, go. Pause your video. Okay, here's the answer to number 1. It was a U-shaped curve. That was a parabola, so that's a quadratic function. Try the next one. Pause your video. Number 2 turned out to be exponential. It has a negative in it, so it's going the other way. It's going down instead of up, but it's the same shape as our other exponential graphs. Try number 3. Pause your video. So what do you think for this last one? Yep, it's linear. We can use a line and connect these. Yep, they're all on the same line. Look at that. So it's a linear function, linear, exponential, and quadratic. These were your monitoring progress problems for a little extra practice. And the last monitoring progress. Tell whether the table of values represents a linear, exponential, or quadratic function. So decide. Do we add the same number each time? Do we multiply by the same number each time? Do you see the pattern? Give it some thought. Write down what type of function you think it is. Linear, exponential, or quadratic. On your mark, get set, go. Did you notice? Multiply by 3 each time. So what does that mean? Do you remember? Look it up in your notes. It's exponential, so it's an exponential function. Okay, good job. And that is the end of our notes. And leads us to Big Ideas Assignment 8.6. Have a great day. Thanks for watching.